According to the National Electrical Code Section 250.104d, an additional electrode is permitted to be installed instead of upgrading an existing water pipe bond under specific conditions. Firstly, the water pipe is less than 1/2 inch in diameter. Secondly, the water pipe material is non-metallic. Thirdly, the water pipe is effectively insulated from the soil. If these conditions are not met, the water pipe bond must be upgraded to meet the required size. In situations where upgrading the water pipe bond would cause significant damage, installing a second ground rod as an additional electrode would be acceptable as per the NEC, provided the previously mentioned conditions are met. Local or utility regulations may impose additional requirements regarding electrical installations, including ground rod placement and bonding. These regulations can vary based on the specific jurisdiction. In general, local and utility regulations take precedence over the NEC. However, if local or utility regulations conflict with the NEC must be followed. To ensure compliance and avoid potential issues, consider these recommendations. Firstly, check with local authorities and utilities for any specific requirements regarding ground rod placement and bonding. Secondly, if possible, upgrade the existing water pipe bond to meet the required size. Thirdly, install a second ground rod as an additional electrode only if the conditions in NEC section 250.104d are met or as permitted by local or utility regulations. Clearly document the situation and the reasons for installing an additional electrode instead of upgrading the water pipe bond. This documentation can be valuable for future reference and inspections. The NEC provides specific guidelines for sizing the grounding electrode conductor, which includes the water pipe bond. The size of the conductor is typically based on the size of the service entrance conductors. When dealing with a 200 amp service, refer to NEC Table 250.66 to determine the appropriate size for the grounding electrode conductor. For example, if the service entrance conductors are copper and sized at 4/0 American wire gauge, the grounding electrode conductor to the water pipe would typically be a number 4 copper. However, always consult the latest version of the NEC and local amendments to confirm the correct sizing. The primary purpose of bonding the water pipe is to create a low impedance path for fault current. This path ensures that in the event of a ground fault, the fault current will quickly return to the source, tripping the overcurrent protective device such as a circuit breaker or fuse. This rapid clearing of the fault minimizes the risk of electrical shock and fire. Ground rods serve as supplementary grounding electrodes. They help to dissipate fault current into the earth, providing an additional path for fault current to flow. The NEC requires that ground rods be installed at least 8 feet in length and driven into the ground to a depth of at least 8 feet. When installing multiple ground rods, they should be spaced at least 6 feet apart to ensure effective grounding. In some cases, local jurisdictions or utility companies may have specific requirements for ground rod placement and spacing. These requirements may be more stringent than the NEC, and it is essential to comply with them. For example, some utilities may require a minimum spacing of 10 feet between ground rods or may specify the type of ground rod to be used. When installing ground rods, it is important to consider the soil conditions. Soil resistivity can significantly affect the effectiveness of the grounding system. High soil resistivity can impede the flow of fault current, reducing the effectiveness of the ground rods. In areas with high soil resistivity, it may be necessary to install additional ground rods or use ground-enhancing materials to improve the grounding system's performance. Ground-enhancing materials are substances that are designed to reduce soil resistivity and improve the conductivity of the soil. These materials can be particularly useful in areas with poor soil conditions, such as rocky or sandy soils. When using ground-enhancing materials, it is important to follow the manufacturer's instructions carefully to ensure proper installation and performance. The connection of the grounding electrode conductor to the water pipe must be made within 5 feet of the point where the water pipe enters the building. This requirement ensures that the bonding connection is as close as possible to the point of entry, minimizing the impedance of the grounding path. The grounding electrode conductor must be securely connected to the water pipe using approved bonding clamps or connectors. These connectors must be listed for grounding purposes and suitable for the materials of the water pipe and the grounding electrode conductor. It is important to ensure that the bonding connection is mechanically sound and electrically conductive to provide a reliable grounding path. In some cases, the water pipe may be made of non-conductive materials such as plastic. In these situations, it is necessary to bond to a metallic water service pipe upstream of the non-conductive section. This ensures that the grounding system is effectively connected to the metallic water piping system. If a metallic water pipe is not available, other grounding electrodes such as ground rods or ground plates must be used to provide the required grounding. The NEC requires that all grounding electrodes be bonded together to form a grounding electrode system. This bonding ensures that all grounding electrodes are at the same potential, minimizing the risk of voltage differences and improving the overall effectiveness of the grounding system. The bonding connection between the grounding electrodes must be made with a grounding electrode conductor size according to NEC Table 250.66. This conductor must be securely connected to each grounding electrode using approved bonding clamps or connectors. When installing a second ground rod as an additional grounding electrode, it is important to ensure that it is properly bonded to the existing grounding electrode system. This bonding connection must be made with a grounding electrode conductor sized according to NEC Table 250.66 and securely connected to both ground rods using approved bonding clamps or connectors. It is important to avoid creating ground loops in the grounding system. A ground loop occurs when there are multiple grounding paths between 2 points, creating a circulating current that can interfere with electronic equipment and increase the risk of electrical noise. To avoid ground loops, it is important to ensure that there is only one grounding path between any 2 points in the electrical system. When dealing with older homes, it is common to find undersized or improperly installed grounding systems. In these cases, it is important to upgrade the grounding system to meet current NEC requirements. This may involve replacing undersized grounding electrode conductors, installing additional grounding electrodes, or improving the bonding connections. When upgrading a grounding system, it is important to carefully inspect the existing wiring and equipment to identify any potential grounding issues. This inspection can help to ensure that the upgraded grounding system is effective and reliable. It is also important to consider the potential impact of the upgraded grounding system on other electrical systems in the building. In some cases, it may be necessary to upgrade other electrical systems to ensure compatibility with the upgraded grounding system. The NEC requires that all electrical equipment be properly grounded to ensure electrical safety. This grounding helps to protect against electrical shock and fire by providing a low impedance path for fault current. The grounding of electrical equipment must be done in accordance with NEC requirements, using approved grounding conductors and connectors. It is important to ensure that all electrical equipment is properly grounded, including appliances, lighting fixtures, and electrical panels. When working on electrical systems, it is important to follow safe work practices to avoid electrical shock and other hazards. These safe work practices include energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment. It is also important to be aware of the potential hazards of electricity and to take precautions to avoid contact with energized parts. The NEC provides detailed requirements for electrical safety, and it is important to be familiar with these requirements before working on electrical systems. These requirements cover a wide range of topics, including grounding, wiring methods, overcurrent protection, and equipment installation. By following NEC requirements and safe work practices, you can help to ensure electrical safety and avoid potential hazards. Remember to always consult the latest edition of the NEC and local amendments to ensure compliance with current regulations. Understanding and adhering to these regulations is crucial for ensuring the safety and reliability of electrical installations. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific electrical installations and upgrades. It is also crucial to be aware of local and utility-specific regulations, as they may have additional requirements beyond the NEC. Regular inspections and maintenance of electrical systems are essential for identifying and addressing potential grounding issues. A properly installed and maintained grounding system is a critical component of electrical safety, protecting against electrical shock and fire hazards. Keeping detailed records of grounding system installations, upgrades, and inspections can be valuable for future reference and compliance. This documentation can help to demonstrate that the electrical system meets applicable codes and regulations. In addition to water pipe bonding and ground rods, other types of grounding electrodes may be used in certain situations. These include ground plates, underground metallic gas piping systems, and concrete encased electrodes. Each type of grounding electrode has specific installation requirements and limitations, so it is important to carefully consider the application before selecting a grounding electrode. The NEC provides detailed guidance on the selection and installation of various types of grounding electrodes. When using a ground plate as a grounding electrode, it must be installed in direct contact with the earth and have a surface area of at least 2 square feet. The ground plate must be made of a corrosion-resistant material such as copper or galvanized steel, and must be installed below the permanent moisture level of the soil. When using an underground metallic gas piping system as a grounding electrode, it must be electrically continuous and have a minimum length of 10 feet. The gas piping system must be free of insulating joints or cuttings and must be bonded to the electrical system at the point of service entrance. When using a concrete encased electrode, it must consist of at least 20 feet of bare copper conductor encased in concrete. The concrete must be in direct contact with the earth and must be located within the bottom portion of a concrete foundation or footing. The concrete encased electrode is often referred to as a UFA ground, named after its inventor, Herbert UFA. UFA grounds are particularly effective grounding electrodes due to their large surface area and consistent contact with the earth. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The grounding electrode conductor must be made of copper or aluminum and must be protected from physical damage. The grounding electrode conductor must be connected to the grounding electrode using approved bonding clamps or connectors. These connectors must be listed for grounding purposes and suitable for the materials of the grounding electrode and the grounding electrode conductor. When installing a grounding electrode conductor, it is important to avoid sharp bends or kinks in the conductor. Sharp bends or kinks can increase the impedance of the grounding path and reduce the effectiveness of the grounding system. The grounding electrode conductor must be run in a straight and direct path as possible. The grounding electrode conductor must be securely supported to prevent it from sagging or coming into contact with other objects. The supports must be made of a non-conductive material and must be spaced at appropriate intervals to provide adequate support. When running a grounding electrode conductor through a metallic enclosure, it must be protected from abrasion and damage. This protection can be provided by using a bushing or fitting that is designed to protect the conductor from sharp edges or rough surfaces. The grounding electrode conductor must be identified by its color. The grounding electrode conductor must be green or bare. This color coding helps to distinguish the grounding electrode conductor from other conductors in the electrical system. The grounding electrode conductor must be permanently marked with the word ground or the letters GRD. This marking helps to identify the grounding electrode conductor and ensures that it is properly connected to the grounding electrode. The marking must be legible and durable and must be located at intervals along the length of the conductor. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This low impedance path ensures that the overcurrent protective device will quickly trip, minimizing the risk of electrical shock and fire. The grounding system also helps to stabilize the voltage of the electrical system, reducing the risk of voltage fluctuations and surges. A properly installed and maintained grounding system is essential for electrical safety and reliability. Understanding the principles of grounding and the requirements of the NEC is crucial for anyone working on electrical systems. Always consult with a qualified electrician for specific electrical installations and upgrades. They can assess the specific conditions and provide the most effective and safest grounding solutions. Also, remember that local or utility regulations may take precedence over the NEC, so it's essential to verify what those are.